This video is about elements and the ions they form. We're going to start off with sodium. The best place to start here is with the periodic chart. This periodic chart has Roman numerals above the groups, which allows us to be able to easily figure out how many valence electrons the element has. Valence electrons are the elements in the outer shell of the atom. These are the ones that are going to be lost to form a cation or going to be added to in order to form an anion. As you can see, sodium is in group 1, which means it's got one electron in its outer shell. If we were to diagram sodium, it would look like this. We'd have a nucleus, and in the nucleus you're going to find 11 protons. Now here's how we know that. We can go to the periodic chart and we see that sodium has an atomic number of 11, which means it's got 11 protons in its nucleus. If it has 11 protons, it's going to have 11 electrons in its shells. And in the first shell it's going to have 2. In the second shell it's going to have 8. This is the same setup for all of the elements. And if you notice, it actually matches what we're seeing on the periodic chart. 2, 1, 2, and then 8. 1, 2, 3, 4, 5, 6, 7, 8. It's not going to surprise you that there's going to be 8 in the third shell as well if we go that far. As it is though, we're only going as far as 11, so we just need one more shell here. And in this outer shell we're going to have only one electron. And this was predicted from this periodic chart here, which said that we're going to have one valence electron because sodium is in group 1. In order to become stable or form a stable ion, it is going to want to either lose one electron, and that will give us a full outer shell here, or it could gain 7 electrons, but it's much more likely just to lose one electron. If this electron is lost, we will be left with an ion. Presently we have 11 electrons, but if we take that electron away, let's do that again. So we'll still have the nucleus, which will still have 11 protons in it. And then we've got 2 electrons and then 8 electrons. And we lost the one in the outer shell. So now we've got 10 electrons left. Now what I want you to be able to see is that if you have 11 protons and 11 electrons, it's neutral, the charge is 0. But if you have 11 protons and 10 electrons, electrons are negatively charged. So what's going to happen is that you're going to have a +1 charge. And the sodium ion will be Na1+. In general, the rule of thumb is as follows. If it's going to form a cation, it will lose as many electrons as it has valence electrons. What does that mean? It means that if it's in group 1, it'll lose 1 electron and become 1+. If it's in group 2, it'll lose 2 electrons and become 2+. If it's aluminum, it'll lose 3 electrons and become 3+. And all of this is explained by the same logic as I'm using here. Let's take a look at what happens with magnesium. Now this time I'm not going to worry about the inner electrons, I'll just worry about the valence electrons, the ones in the outer shell. And if we look at magnesium, what we're going to see is this. Magnesium, and then you've got these 2 valence electrons. And we know it has 2 valence electrons again because it's in group 2. Now it's going to lose these 2 electrons just like sodium lost its 1 electron. And when that happens, it's going to become Mg2+. So it loses these 2 electrons, but it still has the same number of protons in its nucleus. So the charge is now 2+. Let's look at what happens if we have something like fluorine. In the case of fluorine, we'll diagram this one out as well. You've got 9 protons in the nucleus, and there's going to be 7 valence electrons because it's in group 7. So let's see how that works out. So we've got 9 protons. We'll have 2 electrons in the inner shell, and then we'll have 7 in the outer shell. So that's a total of 9 electrons right there. 2 in the inner shell, 7 in the outer shell. The 7 was predicted by the group number. That tells us how many valence electrons there's going to be. Now you've got to ask yourself, is fluorine more likely to lose 7 electrons to gain an outer shell, or is it more likely to gain 1 electron to gain a full outer shell? And the answer is it's going to gain an electron. So we're going to take an electron from the outside here, and it's going to be added to this shell, so it's actually going to gain. Now when we do that, you can see that the outer shell now will be full. We're still going to have 9 protons in the middle, but now we actually have 10 electrons. And if we look at the charge now, it's going to be plus 9 plus negative 10, because electrons are a negative, and that means that the charge is going to be negative 1. So what you're seeing here is that when elements gain electrons, if it's in group 7, it'll gain 1 electron and become F minus. This group 6 would gain 2 electrons and become 2 negative, and nitrogen would gain 3 electrons and become 3 negative. The whole idea here is so that these things can have full outer shells. Let's take a look at oxygen, and you'll see the same thing. So the charge here was F minus would be the answer there. Let's take a look at oxygen now though. Now with oxygen, I'm just going to be concerned with the number of valence electrons. Oxygen is in group 6, so it's going to have 6 valence electrons. In order to become stable, it will gain 2 electrons. And the charge then would be O2 minus. Alright, so just summarizing what we've learned. We can look at the number of valence electrons, and that will give us an idea of the charge that an element will end up having once it loses or gains electrons. If it's in group 1, 2, or 3, it will tend to lose electrons and become a cation. And if it's in group 1, it'll become 1 plus, group 2 will become 2 plus, group 3 will become 3 plus. If it's in group 7, 6, or 5, it will gain electrons in order to form an outer shell, and these will form anions. Group 7 will be 1 minus, group 6 will be minus 2, and group 5 would be minus 3. 4 tends to be something that forms covalent bonds where electrons are shared rather than given away or accepted. So you don't really need to worry too much about 4 forming anions or cations. We'll just concentrate on 1, 2, and 3, and then 5, 6, and 7.